the seed, if we can change the seed, the whole scenario also changes. And we can also select the algorithm from here: PPO, greedy, and ruling LP. And you can also change the color based on severity, priority, and hazard exposure. So based on severity, if we change, then you can see which are the severe zone that is being impacted. So this keeps changing once we start to send the delivered the units or help that is required. We can also now, if we click next step, then you can see the agent being the agent dispatching the goods to each zone. So this blue means it's being sent through air, and this green one, it means that it is being sent through the road. So we have the depot, the inventory sizes, as I've set it to very low purposefully, and then for then at each time step, as you can see, the goods being sent, and this severity is getting low and low. For now, for this demo, I will just run this episode, which will last for 50 time step. So you can see all the red, only few zones having the red zone, and you can see the blockages here. We have blocked, the road were blocked, and the agent have to navigate somehow. If here the road is blocked, then it can send the goods through air mode. You can see the costliest region is obviously the most far away region, which is this region, Tamavu. And you can see all the severity, all the weights and all, and these are the trajectory per time step. And these are all the modes. As you can see, that there were like 6-7 zones which were very highly severe. After those, we were able to, our agent will able to cater to around mostly to the highly severe zone. Only 2 zones were left with the severity of 3. The rest, I think, they've taken good care of all the zones, and they've used all the modes possible, here. And this is the belief head. As you can see, the we have the zone Chitwan where the roads were blocked. Now similarly, if you see the agent, also we can see the predicted, the Chitwan, as you can see, the probability where the road being open was just 0.10. So like this, the agent will predict based on the forecasting, like which zone will be blocked. So this is, we got it from the RNN belief head. So similarly, if I run this all three algorithm at a time, then you can see all the 3 algorithm runs. Now I want to point here that the RL, the LP, the rolling LP, the linear programming, and heuristic greedy, it only optimizes per step by step, so it doesn't have a delayed reward and credit assignment. So due to this, you can see the per step reward gets discontinued after 25 because it runs out of all the stock. So it doesn't have the necessary adaptivity to make sure to last that long. So if I again run this, so you can see, here the units being sent is like they get over by 25 time step. Now if I increase the initial stock size 25, then if I run the same algorithm, you can see it will be able to distribute, and it will distribute for the whole episode, which is 50 time step. But then again, if you see the reward and the cost wise, you can see it's very low. As you can see, the reward, the PPO is able to get much higher, and with the less unit being sent, because it is able to send the units to the most severe zone with little cost. So that's why the our reward was very our agent reward was very competitive. And in terms of efficiency, you can see the PPO performing quite well. So this is my application, and this is all that I have for my final defense and my final research. For my final research. Thank you.